Okay, good morning, good evening, good day to all of you who've tuned in to this informal follow-up session to the Stats Café that was organized last week on land cover change mapping using remote sensing and GIS. My name is Rike Hansen, and I oversee the work of ESCAP on environment and economic statistics. So you will recall from last week that we had a lot of unanswered questions, a lot of comments provided before and during the session, which we did not have time to cover. So this is the reason why we chose to organize this informal follow-up, which hopefully will give all of you an opportunity to get some of your questions answered. And if time permits, we should have also the opportunity to get some new questions and answers raised during this hour. And now quite a few of the questions that were asked related to agricultural statistics, and we therefore decided to reach out to our good colleagues from FAO to help us out with this follow-up session. So it is my pleasure to welcome Sangeeta Dubey, who is leading FAO's work in Asia and the Pacific on agricultural statistics, and Anthony Burgard, who is working with Sangeeta and has several years of experience working on agricultural statistics here in the region, not least as part of the core team that was implementing the global strategy on agricultural statistics, which many of you will be aware of. I want to also welcome back our two main presenters from last week, Ms. Trini Masunda from the Asian Institute of Technology, and Mr. Alat Munusuru, who works here in ESCAP Statistics Division as a GIS expert. So thank you to all four of you for joining us here. I will also introduce you to my colleague, last but not least, Ms. Ayo Marshall, who will be facilitating this 1 hour of Q&A and discussion. So with this, I wish all of us an interesting discussion full of learning, and I'll hand it over to you, Ayo, so please take it away.
Yes, thank you so much. I hope everyone can hear me. Thank you, as Rike said, for joining us for this follow-up session. The intention today is to address the questions and the comments that we were not able to address during the session. We know plenty of you in the audience have different levels of experience and expertise, so we're hoping that this generates a very lively conversation and discussion. Much interest was generated in the topic of remote sensing and GIS and the field of agriculture. So in that sense, we'll start off with Sangeeta, who will address and give an overview of the work that the FAO is doing in this regard. And then we'll continue on with the questions and have some time as well, hopefully, for some live question and answer. So I'll hand over to you now, Sangeeta.
Thank you very much. So let me start by introducing myself. My name is Sangeeta Dubey. I'm the regional statistician for Asia and Pacific for FAO. Prior to coming to the region, I worked in Rome headquarters in the statistics division, leading the economic statistics team. And before that, I was in the Canadian government on various sides of data, from working in a central planning agency to a line department to developing and managing surveys in Statistics Canada. And as many of you probably know, Statistics Canada, the Australian Bureau of Statistics, and some of the European National Statistics Offices have actually led the work in the use of GIS, more specifically the use of Earth observation or satellite data and generating agriculture statistics. In most countries, however, we're still getting there. And there are a large number of GIS experts. There's a large number of experts in the use of Earth observation data. Many of them are in our region at the Asian Institute of Technology. But bringing that bridge between the statistics and this expertise is, I think, a more recent phenomena. In FAO, we've done some work through the global strategy. The first phase wrapped up in 2018 and generated some research publications as well as guidelines on the use of Earth observation data and remote sensing for various uses in statistics, from I wouldn't say land cover mapping so much as mapping for enumeration areas for data collection, but also for crop area estimation and yield estimation. My background is in statistics, but it's not in GIS. So maybe I can share my voyage with you in moving into this space, because many of you who are also of a similar background may face some of the same challenges. So one thing that the use of Earth observation data is limited to is georeferencing. And often that's where traditional statisticians begin. How do we add georeferencing to our statistics in order to map? And the georeferencing has been around for a much longer period of time. It's things like adding postal codes to census data, adding addresses, and which can be mapped against other layers in order to identify exactly where a respondent lives, or identifying the district or the village or the province or state in addition to the country. So that's probably the area of GIS, this georeferencing, that most traditional statisticians are familiar with. The areas that are new to us in agriculture statistics is how do we actually use satellite data or remote sensing data from drones to actually identify crops, estimate the area, the parcel, the plot, estimate the yield. And most of this work has not been led by statisticians per se. It's been led more by GIS experts who may be agronomists, often in collaboration with the hardcore GIS experts. And like I said, in our region, AIT is my single best example in Southeast Asia of this kind of knowledge and expertise. So what can it not do? And where do the statisticians fall in? So just looking at some of the questions that were asked, what it can't do is it can't estimate a crop that isn't visible. It can't estimate very clearly crops that are subject to mixed cropping in the same plot. So it's very useful in things like rice area estimation, particularly where growing rice is a monocrop. But where you're mixing rice and aquaculture, it's not necessarily going to be able to distinguish. Some of the major staples like wheat, it can identify. So there are good types of crops where both area estimation and yield estimation is possible, but then it's also subject to getting good images. And the more accurate the resolution, the closer the image, of course, the better you're able to get the estimation done. But it doesn't rely purely on imagery. So there is still a really important role for, again, the traditional statisticians to do what's called ground truthing, which means you still need to subsample and have someone on the ground actually use a traditional method, because that information then is used to refine the algorithms that identify crops, that estimate yields and so forth. And I've heard the terminology smart sampling. So how do you sample so that you're not replicating all of the work in order to help these algorithms? So there's a role for the traditional sampling statistician to step in. One of the things that was explained to me, which made perfect sense, so I'm going to use the same description. When you take an image from space, you're also subject, particularly when you're using a satellite image, you're subject to the same things that you see when you're taking an airplane. There's cloud cover. There's other obstacles. you can't get a good clear image with those obstacles. So a good part of the work of a GIS expert is to take images over time and get an obstructed view. And that requires a very strong technical expertise. And like many of the most interesting areas of work, that means it's no longer just a traditional statistician that's going to gain that expertise, but bringing the various experts together. My colleagues who Anthony and I work with in AIT are not statisticians. So we help them in terms of understanding what are some of the statistical indicators that we'd like generated on a regular basis. They are experts in doing the imaging, doing the research studies, but their job is not to produce weekly or monthly or annual statistics on agriculture yields or area estimations or what have you. So this is a really exciting time, in my view, for those of us who are statisticians, but not the hardcore GIS AI experts, to work with the people who are, to improve the way in which we use satellite images and to find how our role as traditional statisticians can be used not only to generate databases that then become that historical evidence that can be used for research over time, but that can also be used to consistently produce official statistics, keeping in mind that even official statistics are based on estimations. And those estimations may be sampling weights and adjustments for non-response and the kinds of editing and imputation we do when we think a response is inaccurate. Like I said, the state of art is fairly high. Satellite images are becoming cheaper and more in the public domain. So particularly for younger statisticians, finding the overlap between these two areas can be very interesting. And it doesn't limit itself just to the field of agriculture statistics. It's also used to get estimations of population by looking at things like building and understanding the densities and occupation rates of buildings. It can be used for a lot of other types of urban area statistics as well. It has its use within the broad area of agriculture and counting certain livestock. It can be applied to some extent for oceans and fisheries. What has FAO done? Again, keeping in mind that it's not been the statistics and statisticians that have been leading this work, our new Director General, seeing the merits of digitization use of big data, requested our group responsible for all of the IT work to build a geospatial platform. That platform has now been launched, and it basically takes mostly public satellite data and layers that, brings in statistical data that's geo-referenced to overlay that, brings in other sources of big data such as news feeds to identify where certain newsworthy events are taking place in the world, and brings in climate data, temperature data, rainfall data. A lot of this requires heavy-duty IT background. So this platform, I believe, has already been launched. If it's not already public, it soon will be. But like I said, it was not the statistics division that led because of the heavy IT involvement. It does open the door for more work by the statisticians to regularize studies, but to also bring in georeference data. In the work of the statistics division of FAO, as I mentioned, they produce some guidelines. They are participants, as am I, in the UN Global Working Group on Earth observation data. We do have several country officials that are also part of that working group. It's made up mostly of people who are either experts or leading work. So it isn't closed. It is open for country officials to join. In fact, the organization of this working group is largely run by Statistics Canada. We do also have academic members, both from AIT and from what I believe is Queensland University in Australia. We've got country representatives from Poland, Canada, Australia, among a few other countries. And of course, we've got several UN agencies, in particular FAO right now, and the UN Statistics Division in New York. And I do want to flag before we go over to questions and answers that there is a conference coming up the first week of September on big data for official statistics. And there will be a session during that conference that's very specific to the use of Earth observation data. So hopefully with that introduction, that will help set a bit of the context, and we can now turn to your questions and answers. Thank you.
Thank you so very much. I feel like you've answered all of the questions that came from the pre-session and the ones that came during the session as well. I do have just one follow-up based on what you said. You did say that you believe the Geospatial Platform from FAO was launched. If so, could you just provide some information, more information on that? We can do this after and then share it with all the participants. If it wasn't launched yet, just give us any updates on when it will be. And thank you so much. And we will follow up also on the conference you said that's coming up in September, and that will be of interest to everyone on this call. So we'll share that information as well. Thank you so much. Going on to Chitrini, who is a colleague from the Asian Institute of Technology, as you did mention that you're doing work with that institution. I will then follow up with questions with her. Hi, Chitrini, thanks for joining.
Hi. Yeah.
Thank you. So the one question that we have coming from the pre-sessions and the sessions as well that we didn't get to is and Sangeeta mentioned it as well, she touched on it a bit. To what extent would it be possible to utilize information from ongoing surveys, possibly georeference, to validate this work? Sangeeta touched on it. If you can expand on that for me, please.
Yeah, okay. So before, I think, coming to that question, I should thank Sangeeta because she opened up the context. Yeah. And I'll add to the information she gave, because our group is now working on a little bit on this agriculture thing, in the estimation and stuff, as she already mentioned. And we are trying to do, because she mentioned, like, if there is a mixed crop in some areas, it's sometimes difficult to, map, because when we talk about yield estimation, there are two basically steps, I can say. Like, in the first part, we have to identify the crops from the field. And in the second part, of course, we go for the yield estimation. Although the research is still going on for that accurate yield estimation, but we have, found that for identification of crop types, if we do include the phenology of the agriculture, like using multi-temporal data, using, for example, fused data sets with high spatial and high temporal resolutions, we can overcome up to some extent for case of, even in case of like mixed crops, for example, if we have rice and some other crops. Some of our students are actually working on it, like if the fields have similar crops like cassava and sugarcane, they are trying to differentiate between those using some kind of temporal time series of data sets. Of course, we need a lot of data sets for that. I've not said that we have overcome all the difficulties yet, because as she also mentioned, like we do have issues like cloud covers and stuff. So we are still trying, but this is going in a positive, progressive way to actually accurately differentiate between crop types, which is the first stage of crop yield estimation, as I said. Coming back to your question, how we can, to what extent would it be possible to utilize the ongoing surveys? I think although we say it's remote sensing, we do rely a lot on the ground truth data set for the validation work. So until and unless the ground truth data is accurate enough, we cannot say our analysis also is probably accurate. Because as I come back to my old answer, like when we talk about the, say, crop yield estimation, in the second part, we need to do some kind of modeling, because estimation directly only based on the, say, satellite data set will not be possible until and unless, because what is crop yield? It's basically the outcome of the reproductive stage, right? So basically we need some kind of information in tons, or like all the data from the field for at least modeling stuff. Of course, we can include machine learning to do our models more accurate, but we do rely on these field data sets for making our results more accurate. So that's will be, I think, at least for the present state, like we do need these field data sets to validate our data sets, be it in the agriculture field or even the land cover mapping. So validation must be always there. Yes, Ayo.
Okay, thank you so much. And your response touched a little on the another question about temporal changes and what more can be done in terms of analyzing these temporal changes in the overall analysis. So I'll have you answer that one as well, in terms of including the importance of temporal changes in the analysis. You touched on this in your presentation, and this was one of the follow-up questions. So I'll have you elaborate on that a little more, please.
Temporal analysis in terms of agricultural, or? In terms
of agriculture, because you touched on it with the, the crop yield and
as I was mentioning that when we are doing the crop yield estimation or even the crop species map typing, the temporal inclusion of the temporal can increase the accuracy of the crop type mapping. At the same time, when we are doing the crop yield estimation, inclusion of these temporal stages, because this is the phenology, right? And if we roughly divide the phenology, we can divide in the vegetative stage and the reproductive stage. So this temporal analysis must be included in this analysis. I mean, for estimation of the yield as well. So.
And then in terms of the land cover change, how important is the temporal analysis and how is it used in terms of mapping land cover change?
Temporal analysis, if you see through the term, it's basically analyzing the change. Temporal means different time periods, okay? So, I mean, of course, we do temporal studies in two major ways. Maybe it can be a discrete changes or it can be a continuous changes. In discrete, I can say like, okay, year by year. I mean, you can choose particular years and do the temporal changes. In say continuous study, we do a very dense time series of analysis where we take like hundreds of probably images and do time series analysis. So that's the two major different temporal changes. Now, depending on the purpose of study, that day also I mentioned that it depends on what is your focus on, like based on which you decide what type of temporal analysis you are doing. I mean, whether you are just focusing on some major changes of urban, or you are actually looking at the seasonal changes of probably the agriculture or climate or environmental parameters. So it depends on like what kind of temporal changes you are looking at, and it will be always based on the purpose of your study.
Thank you so much. I think Sandy has her hand raised. She wanted to jump in. Feel free.
Yes, sure.
Please do.
So I just wanted to remind everyone that even in traditional statistics, all the new innovations started with research before they became mainstream. And the same thing is occurring here, that it's the experts in the use of remote sensing that are doing the phenomenal work. The statistician then comes in and says, how do we convert this work into regular statistics? So you mentioned this issue of temporal change in land use. Now, when you think about an image, right, there's an infinite number of points. And one of my colleagues that works in ESRI, which is probably the most famous private sector firm in supporting countries and organizations and doing and presenting geomapping and statistics. So think even about the Johns Hopkins Medical Center's Coronavirus Center. ESRI is behind that. Think about the WHO COVID-19 center maps. ESRI is behind that. And what my colleague said really stayed with me. He said, at the end of the day, he's an IT person. He thinks in terms of databases. That resonated with me because as a statistician, I think in terms of databases. How do you put everything into a database? The most simplest way to think of it is, how would you put it into Excel in a database in a format that you can create a pivot table or you can run a regression? But land area is continuous, which means that there's an infinite number of points and you can't have an infinite size database. So you have to think about how do you divide a land geography into discrete units? What should the size of that unit be? How do you measure that area? And then if you can generate statistics that geo-reference those units, right? So think of a map where you're creating a grid. Then you can do an estimation over time. What percentage of land used to be agriculture and now has become urban? Or what percentage used to be rural and is now urban? What percentage used to be used for crop production and is not? Either, and has it become fallow? Or has it become used for industrial purposes or converted to roads or some other use? What percentage of the land area under agriculture in Laos was flooded? We knew the floods from over a year ago, not over a year ago, I think, yeah, almost a year ago now, actually caused movement of some villages into other areas. What percentage of that area was there? So one of the things that we bring is thinking in terms of this database structure of how are we going to create official statistics on an ongoing basis that have time as one element. And that time can be in official statistics, it can be annual or monthly. But with the use of remote sensing, we can get it into more real time. We can get it weekly or even daily if we want, right? So how do we start thinking about structuring this information into a database? What are the indicators we need? And then how do we work with our GIS experts to say, is this feasible? Because our thinking is at some point going to overlap and expand because of our conversations. And our GIS experts like Chitrini will come to us and say, have you thought of this? Have you considered producing this indicator? That's what for me makes this work really, really exciting. And we have to learn enough of each other's language that we can communicate, but we shouldn't dumb down our own language, because what I do find is when we dumb down, we assume the other knows what we're talking about, and we don't give each other the opportunity to look at the same phenomena from a different perspective. So this field is going to evolve, right? It is going to evolve. And as we challenge each other, I think it can be really, really, really exciting. And let's not forget, we're in a world right now where movement is very restricted. But it's not. But satellites are not. They're moving constantly, right? So the world has also presented us in these very difficult times an opportunity to take this area of work and accelerate it. And so I do hope that our conversations will continue, bringing in the GIS experts, but also the statisticians. And I hope many of the statisticians who are on this call will also post their questions.
Hi, thank you so much, Sanjita. Thank you, Chitrini, as well. Anthony, is there anything you wanted to add to any of the questions that have been asked, or anything that Sanjita or Chitrini has said? The floor is yours. You're on mute, Anthony.
Apologies for that.
Oh, sure.
So I think one key point that I picked up from both of the previous presenters is that we have to keep in mind that what does it mean to classify land data for agriculture, right? It's a way, the classification process is a modeling process. We're trying to estimate or try to get an idea of how much of land is agriculture. So the way that I guess remote sensing works in a way is that we're looking at some satellite imagery and we're trying to measure some piece of light that is reflected from that imagery. And based on that light, we're trying to figure out whether that measurement of light can tell us whether that piece of land is used for agriculture, for forestry. But the problem becomes is that because we are doing a modeling approach, we're trying to figure and estimate land, is we have to also figure out how accurate is our estimate. And that's comes to the issue of the ground truthing that was brought up by both Sangeeta and Chatrini. And ground truthing, there's been various methods over the years, and different agencies have approached this in different ways. I just wanted to talk a little bit about those approaches. So the most traditional approach is that the GIS experts in the past have done traditional surveys, where they'll go, once they've done the classification of the image, they'll travel to that piece of land to confirm whether or not that land is in fact classified as agriculture, forestry, or urban buildup. However, over the years, we've also seen different types of approaches being used. One example I can bring up is the example from Statistics Canada, where they have used their long time series data from their administrative reporting system to help inform their remote sensing estimates. Another example that I can bring from our colleagues from the National Bureau of Statistics in China, who are using drone and high-resolution satellite imagery to help inform this ground truthing process. So those are some of the different examples of how countries are beginning to utilize and try to figure out what is the role of the National Statistics Office in validating these remote sensing models to help us to better understand how do we classify the land of our country and how it is used. Okay.
Thank you so much. That touches on a number of the other questions that we had in terms of the validation techniques and the procedures being done. So thank you for keeping the conversation going, because these are questions that did come up. So I'll move on to our next presenter, Alad. Could you answer this one? Someone asks, do you run any spatial correlations to confirm the visual pattern observed with R as well? So this is in the whole theme of the validation techniques and procedures. So I'll ask again, were any spatial correlations run to confirm the visual pattern observed with R? Or do you run any, or are you planning to run any?
Right now, I hadn't run any spatial correlation techniques on R. It's directly based on the pixel values and on the number of pixels it is present on that each land cover classes. I have used the math on that to multiply based on the number of cells on each land cover classes and run a simulation for all the images. It can generate the complete land transition matrices. But correlation techniques we are planning to do on some other add-on on that. When we completed these land transition matrix, everything, we have this every distinct years, and we can analyze the rate of change among the countries, where the land cover been changing, something like how the urban was varying among the cross countries. These are some correlation and validation comparison techniques we are trying there. But right now we hadn't done, but we are in the research oriented direction on that.
Okay, thank you so much, Alad. Any of our other presenters or anybody in the audience wants to add to anything that was said so far, or any of the questions that were asked?
I can add a few things if there's time.
Oh, could you speak up, please, Sohail? Thanks for joining us.
At the end of the day, the concentration is using historical data so far. The new data, we have very, very high resolution, and you can basically apply more fancy techniques. But right now, the concentration of what has been developed so far was using data from the 1994s, let's say 2005 to 2015, and we stopped there. Most of the satellite images provided by MODIS and ESA for the land cover has been already programmed and modeled in order to identify some classifications. And there are literature on the accuracy of these classifications. I'm talking about 300 by 300, 250 by 250. And we all acknowledge that the accuracy of every single one of them is less than 70%. So we have to take whatever data and estimates we generate with a grain of salt, that this is plus or minus. So, and it's 70% accurate and 30% could be completely not accurate. But at least it's better than 50%. You see, it's not yes and no. So that's one aspect that we have to understand that. So what exactly is being done for the land change matrix based within the statistical framework of the system of environmental economic accounting. So I don't think the data we have can basically identify what type of crops we are basically generating. SIA does not even ask for that at this moment. It's just a basic land account for member countries to produce their initial SIA land account and land cover change market. Now, most of them, they produce two cross sections. They take 2005, let's say, 2015, and they say they change in kilometers square or hectares. Even in that, I'm not that comfortable with. So what ESCAP ST has been initiating is do not take two cross sections, generate land cover change matrices every single year, and run a regression and publish the rate of change, the derivative, as opposed to two cross sections. So this adds a little bit in terms of appreciation of what land did change in terms of the rate of change. And on top of that, ESCAP is trying to basically aggregate all of these 32 or 12 classifications into very simple 5 4-level classifications. And that will even add in terms of the overall accuracy when a national statistical office publish their data. Because there's a difference between the agriculture department publish their data versus the statistical department publish the data. You see, there's two differences there. One comes from the national account perspective, and one comes from a particular subject of matter of interest. So I think this needs to be somehow acknowledged when satellite images are used for a system of environmental economic accounting publication. Thanks.
Thank you so much, Suhail, for those reflections and for outlining the different uses by the different sections in the National Statistical Offices. Does anyone else have anything else to add? Okay, I'll go on. Hi, Eileen. Yes, I see your hand raised.
Hello, just I know I'm not like just to fill in with and from the discussions and from Sangeeta and the previous speaker. So I was just thinking. So we started talking about conversation about this, which is evolving and will continue and will therefore continue to contribute to the changes and continuing improvement of this type of statistical production. But there were questions on data accuracy and the need for having a classification that is understood by both statisticians and practitioners, and therefore leads me to my question on how do we resolve data reconciliation, because at the end of the day, we want while we recognize that there is like 70% accuracy and there's 30%, how do we reconcile now some of the data that is existing with this type of remote sensing so we can improve this data accuracy? And what are the platforms that will need to be in place so that we can continue to have this type of conversation that would lead to a more unified or harmonized approach in doing this type of work? And I guess just going with the Sohail's earlier discussion, I think the main, as I understood, the main goal of this ESCAP project is basically to start this type of conversation. I mean, that the platform is there to showcase and draw interest so that more people would be and stakeholders, especially the countries, would be able to appreciate it more because, you know, the visuals help and having a ready platform helps. So I think my point being, how do we then evolve as a group, I guess, in order to make this type of conversations lead toward greater data accuracy and more of this reconciliation of information and data that we have. Okay, that's all, Ayo.
Oh, thanks, Eileen. Anyone, feel free to answer or address. Sure. I see your hand, Sangeeta.
Great. I'm very glad Eileen has raised some of these questions. Platforms. I want to tackle that one first. So there is work that's been done by the UN Statistics Division in having a global platform on satellite images. There's a number of space agencies that make images available for free, including NASA, including the European Space Agency. One of the issues that's come up is, and this is a pet peeve of mine, it's very, very easy to talk about development of a platform, you know, development of a new dissemination platform. Over time, it's an easy sell to donors, it's an easy sell to managers, you get a good IT person, you've got a platform launched. The problem becomes in maintaining it. And maintenance and updating can be very expensive. So I've seen too many statistical platforms that get a lot of attention in the beginning, and then they become 5 years old, 6 years old, 7 years old, 10 years old. No one's maintaining it, but it's taking up space and it's a distraction. So there's also been discussions with this UN-led working group, global working group, which is not, because it's a UN working group, it includes very, very prominently NSO's country officials, about not doing all this duplication. And of course, after saying this, we see this duplication within FAO itself with this geospatial platform. But the reason is the UN Working Group platform was more about statistics. This geospatial platform is more about analysis. So I think one of the things that we have to resist ourselves is jumping to create yet a new platform, because satellite images don't respect national boundaries, right? So it doesn't make sense the way it does for survey data, which do respect national boundaries, to start talking about multiple platforms, even across UN agencies, right? So one thing that at least the FAO geospatial platform has done is it allows countries to share their images, to share them publicly or to share them privately for their own use. So they still have access to all the global data, all the global public goods. They can keep their private data private, and they don't have to jump to creating a new platform if they don't already have one. That's one thing I wanted to raise. Eileen raised the question of reconciliation. We face the same problem in any statistical surveys. I run a sample survey from the labor force survey to get on employment labor force data. I run that monthly. Then I do an annual survey on labor and income dynamics, and I get different results because the samples are not the same. So as statisticians, we're already faced with this issue of reconciliation. And we have to manage well, which means we're always in conversations with the other data producers. In agriculture statistics, that's one of the reasons why FAO emphasizes having not just the statistics office participate, but also the line ministries, because often in a country, the statistics are not just collected and disseminated by the National Statistics Office. And when I'm referring to agriculture, I'm referring to the National Accounts definition of agriculture that includes forestry and fisheries. I can't say that I have the solution, but I can say that we're finding the solution in this kind of dialogue and making sure that our GIS experts and our statisticians are dialoguing, because we're not going to have the others' full expertise, but the more we can communicate together, the more we can create ways to ensure that reconciliation is built in the modeling, that we challenge each other, and that we understand that where differences do occur, it could be because of timing, it could be because of sampling, that we document that very well in metadata, so that we're not putting our decision makers in a quandary of which statistic is the right statistic, right? So I think that's really important, and we do better work. But I should also mention there's a whole new set of players that come into this field that we haven't talked about. Anthony mentioned the use of drones to validate crop identification, because they can take pictures from much closer. And you know, I've heard this comment from people who are not GIS experts. I would have made this comment 3 years ago. Well, why don't we go to drones? They're cheaper. You know, you can go to an electronics store, you can buy a drone for $100, but you cannot buy a drone that captures images that is able to carry the cameras for $100. You're talking about $10,000. One of the AIT groups has actually developed an open design that can be used to build a drone for $2,000. $2,000 is not cheap. This is US dollars. Then you have to consider, if the drone is large, how do you transport it to the field? And often that means that you need a vehicle. It's not one person who is carrying it, like one enumerator would carry a questionnaire. You've got to have someone who's piloting the drone. You need a spotter. So you can start seeing the cost going up. And to give you a practical example, Anthony had facilitated some Chinese experts who use drone technology to do a technical mission to Timor-Leste. They were going to conduct their first ever agriculture census, and they were interested in exploiting technology. And so the mission took place. Our Chinese experts took the drones over, showed how it was used. But when they realized the cost of getting enough drones, having experts to fly them, to spot, transport them, it was prohibitive. And it wasn't useful because we hadn't thought through yet exactly how are we going to use the images? What is it that we're going to be doing in terms of the statistical work? So it's good to have this conversation, but we have to be aware that the costs are not yet at the point, or for most uses, things like privately owned technology is feasible. And we also have to keep in mind procurement processes. So we've even talked about something that's been around for much longer, the use of tablets for data collection. We've had countries that have faced barriers to procurement, you know, following their own procurement rules. So do be aware that while this technology use is really exciting, there's some practical issues that also need to be dealt with. So it's not going to happen overnight. The last set of players that become really important, when you start getting into any kinds of satellite images, particularly if you're also looking at high resolution, you get into security issues. So all of a sudden, we no longer just have the NSO and the agriculture line ministries involved in agriculture statistics. We're going to have sometimes the land registry departments or the ministries responsible for satellite images. We're going to have a national space agency, and we are going to have, believe it or not, national defense. Because satellite images can start taking pictures at a level of detail in secure areas of a country. And you don't want to be in a situation where you run against that problem without thinking it through. That national defense also means that when you've got drones out, you have to consider if there's any laws that are being violated in terms of privacy, in terms of security with the use of drones. You have to get local authority permissions. So there's a lot more partnership aspect to using any kind of remote sensing than there has been in the past in going through with the traditional pen and paper or even CAPI surveys. because the traditional ways of doing surveys have already addressed the issues of privacy, confidentiality, the right of enumerators to go into certain areas. So it's not like that hasn't been faced already, but that's been addressed by and large. In moving towards this use of remote sensing, we need to remember that there are a lot of new players in national security and defense, and privacy are the three big areas that we still need to address at the national level, and they may become prohibitive just because of concerns. And so where the greatest successes happen in any kind of e-agriculture strategy from FAO has been when our officers have actually convened the stakeholders right from the beginning. So they're aware of the limitations, they can understand where the space they can play in and the space they can't. I don't know that it addresses all of Eileen's questions. I think more it reinforces that her concerns are still things that we need to work on, and progress is being made. Over.
Oh, thank you so much. It does address some of the questions that have been raised in the chat box as well. Aisha has asked about NSOs investing in drones and similar equipment, but you have outlined how cost prohibitive that is. Hopefully these kinds of conversations can carry on and will make the process easier. Thanks for outlining the practicality and the issues there as this process and the GIS remote sensing becomes more and more an issue that people are working with as well. So thank you so much. I will just ask one more question of Alad, and this one came as a result of your outlining the land cover change using QGIS and RStudio. With the creation of a Shiny app to wrap around the model that you created in terms of the methodology, would you be able to do a Shiny app to wrap around that and provide a service based on that? So please answer, Alad.
Yeah, this Shiny apps are quite interesting, and basically we can have a high resolution dashboards which we can clearly show the picture. But regarding the national scale analysis, if we convert this using R from raster to vector data sets, it will take minimum 3 to 4 days to run the model, and it's not recommendable at that session if we use that, but we should find some other alternative ways on this. But one of my colleague was doing intense research on this. She has developed some quite results. Linda, she had developed some quite interesting results, but it's still progressing on that. It's not promising, but we are doing that.
Okay.
Yeah.
Thank you so much. Thank you so much for answering that as well. We had a couple comments coming from the live chat box when we did the Stats Café, and one of the participants, Gary Dunnett, I'm not sure if I'm pronouncing his name correctly, he had indicated that there was a real use case for this work in the production of agriculture statistics as per the NASS in the US. I see that he's on this call, so I've put him on the spot. If he wants to give some more information on that NASS case, we weren't able to address it in the Stats Cafe, but if you don't mind, you can elaborate on that. Is Gary here?
Yeah, I'm here. I actually think, can you hear me okay?
Yes, we can hear you.
Yeah. I actually think Dewberry has talked about it quite a lot. It's but if you go to the NAS website, they have a number of applications where you can actually drill down to a very fine level, and I know that they're actually using satellite imagery to make calculations and vegetation density calculations, very regularly. So I think you've sort of covered it quite well today. And I know that such issues, are of importance to many Asia Pacific countries, with SDGs, through deforestation and aspects like that, and sort of rising waters, sea waters, and that. And I think so. That's where I think this application of satellite imagery and what have you is very real and very applicable to national stats offices of the Asia Pacific region.
Thank you so much. And also one person who was pretty vocal in that Stats Cafe and is vocal here as well in the chat box is Regis Borgold. He indicated that he worked on flood prediction projects in frozen and desert areas in 1997 and 2018. So I'm going to put him on the spot and ask him to talk about the projects that he worked on using different tools and what tools he used. Are you here, Regis?
Yes. Okay. Actually put my pretty face on. Maybe. Can you hear me?
Yeah.
Okay,
yeah,
yes, I'm a science officer. In 97, actually, I started to use a radar sat back in 96 during the crisis in Rwanda. And it was mentioned earlier to do ground proofing. So I was actually flown to Germany and from there to Rwanda to try to identify the signature of certain things that were bouncing back. And it turned out to be that they were canvas used by the refugees as they were escaping from the second exodus outside of Rwanda. In 97, there was the major floods that took place in northwest, in western Canada, in Manitoba, and North Dakota, Minnesota. That year, it rained a lot, and in spring, a lot of snow before that, and it was cold, so the water had no place to go, so it went down to the Red River, and we had to save Winnipeg by all means. And we used all the technology, the survey that was done during the colonization, if you may say. So the Western, and everything was surveyed to the nearest tenth of a foot. At that time, there was no technology to give us more accuracy than that. So we used that, converted it, joined the dots, and created a 3D model. And then based on that, we could determine where the water would flow. And because of that, we could deploy the troops faster to retrieve people. And in 2018, was it 18? I said 18?
Yeah, you said 18. Do share the experience.
Yeah, okay. In 18, there was an ABA between North and South Sudan. I was called to go over there because my background is also, I'm a terrain analyst, but a topographical surveyor. And we had to use old maps, geological maps of the area and satellite imagery. And we did, of course, temporal confirmation from time to time to do that, but also in missions in MONUSCO, which is in the Democratic Republic of Congo. When the missions leave, close stations, then we have to give the land back the way it was when we were given by the government. And so we also went back to old imagery and built up to the way it was before and after. And we realized that everywhere we put a cam, people would come closer because they could get electricity, water, and things like this. And they modified the whole environment there. The footprint that was left was much bigger or damageable. And I think we use also the satellite imagery for the Onissi, which is a mission in Côte d'Ivoire, where there was fuel spillage. And then we managed to bring back the soil, the contaminated soil, and clean the whole place and handed back the land to the government the way it was before the spillage and things like this. There are many ways to do that. And like I mentioned also in Congo, we developed the SOPs because we were we were the first ones to develop this drone project and for high resolution mapping and also surveillance. I was part of the working group. We developed SOPs and a lot of things. Now the missions are using more and more drones, especially for surveillance and reconnaissance purposes.
Well, okay. Thank you so much. Thank you. I think we have just about enough time for one more question from the floor. If anyone wants to ask very quickly before we wrap things up. First person to raise their hand or sound their voice in the meeting chat. If not, I'll hand over to Rike to close off the session. I'll count down. 3, 2, Okay, thank you so very much to everyone for joining and for engaging in this very, very, very lively conversation. Thank you so much. And I'll hand over to Rike.
Yeah, thanks, Ayo, and thanks to all of you. Particular thanks to our 4 resource people who really managed to help us dig much deeper into some of the issues that were raised last week, but also raise a number of new issues. So I'm not going to do a full summary here in 30 seconds. So actually it's 12 o'clock here in Bangkok now. But I do see a lot of opportunity to continue this dialogue among the people in this call, but also people who are interested in the various different tangents of the discussion that has happened during the past hour. Well, as was mentioned last week, the starting point for even inviting for the discussion was the work of ESCAP Statistics Division to help build capacity in the region for SIA land accounts, and look where that has taken us this week in the discussion. What I will do is to pick up after today, pick up a conversation with Sangeeta and Anthony at FAO. I want to thank the 2 of you particularly for joining us to see whether we can find ways of continuing this dialogue, maybe as a collaboration between ESCAP and FAO. And I'm happy to see Sangeeta nodding. But let's call it a day for today. And thanks a lot to all of you again. Plenty of work done, plenty of work to still be done. So do have a good continuous day or night, depending on where in the world you're at. So thank you again, and I'm sure we'll have the opportunity to talk more. Thanks. Okay. So goodbye, everyone.
Bye. Thank you.
Bye. Thank you.
Thank you.